Okay, so we are picking up from where we left off last class, where we were looking at constructing quadrant 1 of the unit circle. And so far what we've figured out is we've had our coordinates here for every 90 degrees or every pi over 2. And then we figured out in our first quadrant that for 45 degrees, the coordinates here are at rad 2 over 2, rad 2 over 2. For 30 degrees, it was rad 3 over 2, 1/2. And for 60 degrees, 1/2, rad 3 over 2. And so again, just kind of labeling, this was 0 degrees or 0 radians, as well as 360 degrees or 2 pi radians. This was for 30 degrees or pi over 6 radians, 45 degrees or pi over 4 radians, 60 degrees or pi over 3 radians. This was 90 degrees or pi over 2 radians, 180 degrees or pi radians. This was 270 degrees or 3 pi over 2 radians. So the way we move into other quadrants is we take this same idea. So if, for example, I wanted to look at 135 degrees or 3 pi over 4 radians. Here is my angle. Now, when I'm going and making my right triangle with the x-axis, here's x, here's y for my x and y. What I notice is that my 3 pi over 4 is actually outside of that angle, or the 135 degrees. What I need is this angle. Well, when we're in quadrant 2, this angle that I need and the angle that I'm looking for, the 3 pi over 4, are supplementary. So this is going to be 180 degrees minus the 135 degrees, or 45 degrees, or pi minus 3 pi over 4, which is pi over 4. And so what I have now, if I work off to the side here, is here's x, here's y. I know the radius is 1, so my hypotenuse is 1, and this is a 45 degree angle. Well, we have an isosceles right triangle of 45, 45, 90, like we did yesterday when we looked at 45 degrees. The only difference here is instead of moving right and up, we're moving left and up. So now, when I'm saying this is A, this is A, this is A radical 2, and I get that A is 1 divided by radical 2, or once that's simplified, radical 2 over 2. I am moving up radical 2 over 2, so that's y, and that's going to stay positive. But now when I'm moving left, because I'm going from the origin left then up, because I'm moving left, the x has to be a negative number, because that's my coordinate. So I have negative radical 2 over 2, positive radical 2 over 2 for the coordinates. But what this now means is that if I wanted the cosine of 135 degrees, that's the x-coordinate. That's going to be a negative radical 2 over 2 because I had to move left negative before I went up. We're going to run into similar things when we work with our other angles here with 120 degrees, which is 2 pi over 3, or 150 degrees, which is 5 pi over 6 radians. When we work with those, we're going to get coordinates where they're going to be mirror images of the 30 degree and 60 degree angles, but the x's have to be negative because we're moving left, not right. So for 120 degrees, it's like the 60 degree, but instead of moving to the right 1/2, I'm moving left 1/2, but still up rad 3 over 2. And for 150 degrees, I'm moving left radical 3 over 2, but still up positive 1/2. When we get into quadrant 3, then we're going to have to deal with the fact that we're moving left and down, so the x's and y's are both negative. So cosine and sine are both negative in quadrant 3. In quadrant 4, we're moving right, so the x or cosine is positive, but we're moving down, so the y or sine will be negative. And so in the notes page that you pick up today from the card at the front of the room, you'll see two things on the front of it. One is, I know the reference angle thing is kind of tough, and it's kind of by quadrant how we figure out the reference angles that are going inside that right triangle being formed by connecting the end of the terminal side to perpendicular to the x-axis. These are some rules, both in degrees and in radians, to help you find those reference angles. But then, because cosine is my x-coordinate, sine is my y-coordinate, and tangent is sine over cosine, each quadrant here is a way of saying how it is. Because x is positive and y is positive, that means since x is positive, cosine is positive, y is positive, sine is positive, and tangent is sine divided by cosine, so positive divided by positive, still positive. So y over x is positive. We can say in quadrant 1, all three of our main trig ratios, sine, cosine, tangent, have to be positive. In quadrant 2, the x is negative, so cosine is negative. Y is positive, so sine is positive. And tangent is sine over cosine, while a positive divided by a negative is negative, so tangent is negative. In quadrant 3, x or cosine is negative, y or sine is negative, and tangent is sine divided by cosine, and a negative divided by a negative is positive, so in quadrant 3, just the tangent is positive. In quadrant 4, x or cosine is positive, sine, y, is negative, and tangent is sine over cosine, and a negative divided by positive is negative, so only the cosine is positive. And a mnemonic to help you remember this by quadrant, all positive, sine positive, tangent positive, cosine positive, is the phrase all students take calculus. So all students, sine positive, take, tangent positive, calculus, cosine positive. So an example of how this can work is, let's say I wanted the sine of 5 pi over 6 radians. So in my unit circle, 5 pi over 6 is in quadrant 2. It has a reference angle of pi minus 5 pi over 6, which is just pi over 6. And the coordinates where those meet, the x is a negative rad 3 over 2, and the y is a positive 1/2. Sine is the y-coordinate, so sine is a positive 1/2. And that's the second quadrant, sine should be positive.